Why this vehicle made engineers question their own training. At first, no one trusted it, not even the people who built it. The data looked wrong, the behavior felt wrong, and the conclusions it forced were deeply uncomfortable, because this vehicle didn't just challenge competitors. It challenged everything engineers have been taught to believe. To understand why this machine caused such quiet panic inside development teams, we need to return to the foundations of automotive education. Engineers are trained to think in boundaries. Loads must flow along predictable paths. Systems must be isolated to be understood. Problems are solved by breaking them into smaller, controllable pieces. This vehicle refused that logic. From the earliest simulations, it behaved as if those rules were optional. Stress didn't concentrate where models predicted. Components interacted instead of isolating. Improvements in one area amplified performance elsewhere instead of introducing trade-offs. Every result contradicted the assumptions that decades of textbooks treated as law. At first, the team assumed error. They rechecked models, rebuilt simulations, validated sensors. Independent reviewers were brought in to audit the work. Each time, the conclusion was the same. The vehicle wasn't breaking physics. It was exposing how incomplete their understanding had become. The architecture behind it was deceptively simple. Fewer components, fewer interfaces, but each part was designed to serve multiple roles simultaneously. Structure became thermal management. Aerodynamics influenced stability and efficiency at once. Control systems responded to the whole vehicle, not isolated subsystems. This integration made the vehicle difficult to analyze and impossible to reduce. Engineers trained to optimize parts now face a system that punished isolation. Remove one interaction and performance collapsed. Adjust a single variable and the entire behavior shifted. The vehicle could not be understood the way they had been taught to understand machines. And that realization cut deeper than any technical challenge. Because if this vehicle worked, and all evidence suggested it did, then the problem wasn't the car, it was the training. The very frameworks engineers relied on to make sense of complexity were suddenly insufficient. Years of expertise felt fragile. Confidence gave way to humility. And in that moment, the vehicle stopped being a project. It became a question, one that asked whether the industry had been solving problems, or simply repeating methods long after their usefulness expired. That question would not stay contained for long. That went against everything they knew. Design reviews grew tense. Senior engineers questioned assumptions they had taught for decades. Younger engineers hesitated to speak, unsure whether they were witnessing a breakthrough or a misunderstanding too large to articulate. The vehicle didn't fit into existing categories of thought. Training had taught them to optimize locally. This machine demanded global thinking. When teams attempted to isolate variables, performance collapsed. When they allowed interactions to coexist, efficiency rose. The vehicle behaved like an ecosystem rather than a machine, each element influencing the others continuously. No single component was responsible for success. The success lived between them. That realization unsettled leadership. If engineering could no longer be compartmentalized, entire organizational structures were at risk. Departments existed to manage separation. Careers were built on specialization. Certification processes assumed isolation. This vehicle challenged all of it, not aggressively, but by working too well to ignore. The more they tried to explain the vehicle, the less confident they became in their own explanations. Some engineers embraced the discomfort. They began relearning fundamentals, questioning first principles instead of inherited rules. They studied systems theory, biological networks, and complexity science, fields rarely associated with car design. Slowly, a new language formed around integration instead of optimization. Others resisted. They warned that abandoning proven methods invited chaos. That education existed for a reason, that this vehicle was an anomaly, not a direction. The tension split teams along philosophical lines. Reduction versus synthesis, control versus emergence. The vehicle continued performing flawlessly through it all. It didn't care which framework was applied to it. It simply responded to reality, absorbing forces, distributing energy, adapting behavior as a unified whole. It was indifferent to the discomfort it caused, and that indifference forced a painful truth into the open. The vehicle wasn't difficult to understand because it was flawed. It was difficult because it was ahead of the mental models used to evaluate it. And once that gap was exposed, engineering education itself became part problem. The question no one could escape was no longer how to improve the vehicle. It was how to rethink the way engineers were taught to think at all. The internal conflict reached a breaking point when the vehicle entered extended validation. Months of continuous operation under varied conditions produced results that were impossible to dismiss. Reliability improved instead of degrading. Efficiency stabilized instead of drifting. The system aged gracefully, not because it was protected, but because its interactions balanced where naturally. For many engineers, this was the moment their training truly failed them. They could no longer explain why the vehicle improved with use. Traditional models predicted divergence, not convergence. Components should have drifted apart. Instead, they seemed to settle into harmony, compensating for each other as tolerances shifted. The vehicle behaved less like a machine wearing out, and more like a system learning its own limits. That behavior shattered assumptions. Maintenance teams noticed it first. Service intervals lengthened without instruction. Minor wear corrected itself through redistribution of load. Software interventions became rarer over time. The vehicle demanded less attention the longer it existed, an outcome no design manual accounted for. Engineers argued late into the night. Some insisted this was coincidence, statistical noise, a rare alignment of variables unlikely to repeat. Others pointed out that the architecture encouraged equilibrium, that by allowing systems to influence one another openly, stress never concentrated long enough to cause cascading failure. The disagreement exposed a deeper divide. One group clung to predictability. They wanted models that explained everything before it happened. The other accepted uncertainty, trusting that systems designed to cooperate could adapt better than ones designed to be controlled. Leadership watched the debate carefully. Adopting this vehicle's philosophy would require retraining teams, restructuring departments, and rewriting validation frameworks. It meant admitting that decades of education emphasized control over understanding, that engineers were trained to eliminate uncertainty instead of working with it. The risk wasn't technical. It was cultural. Eventually, a compromise emerged. The vehicle would continue, but its philosophy would not be declared a new standard. Officially, it would be labeled a special case, an outlier, a learning opportunity rather than a template. That decision satisfied no one, because the engineers who worked on it knew the truth. You don't need many examples to expose a broken assumption. One working contradiction is enough. And this vehicle was exactly that. It proved that engineering education had not prepared its practitioners for systems that could not be reduced, isolated, or fully predicted, systems that required humility instead of control. The vehicle didn't just challenge methods. It challenged a resolution arrived without a declaration, but with a shift. No new doctrine was announced. No textbooks were rewritten overnight. Instead, something subtler and far more powerful took place. Engineers changed how they approach problems. Those who had worked on the vehicle carried its lessons quietly into other projects. They stopped optimizing parts in isolation. They began asking how forces flowed through entire systems. They designed interfaces to cooperate instead of compete. They allowed uncertainty to exist without rushing to eliminate it. The industry didn't reject its old training. It outgrew it. Universities noticed the gap first. Graduates entered the field fluent in equations, but uncomfortable with emergence. Research programs began expanding beyond component optimization into systems thinking, complexity theory, and interdisciplinary design. The vehicle was rarely mentioned, but its influence was unmistakable. Inside companies, validation frameworks slowly evolved. Testing focused less on perfect prediction and more on behavior under change. Engineers learned to observe before intervening, to trust patterns instead of forcing outcomes. The idea that a machine could stabilize itself no longer sounded reckless. The vehicle itself never became a mass-produced template. It didn't need to. Its role was catalytic, not commercial. It existed to break certainty, not to replace it. And once certainty breaks, Progress accelerates quietly without permission. The vehicle that made engineers question their own training didn't leave behind a product line. It left behind humility. And in a discipline built on precision, humility turned out to be the most important upgrade of all. Because when engineers learn to question how they think, not just what they build, the future opens in ways no blueprint can predict. Sometimes the smallest shift in perspective becomes the beginning of a new future. Why